Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in the JEE Mains 2021 revision series. And in this new year, I'm very happy to present to you the first video of this series on the topic of kinematics. So there will be different topics that I'll take up the videos on this particular series, and there'll be somewhere around 20 to 25 videos I have planned topic wise to debate the most intriguing previous year's questions of JEE mains to help the students go through their last leg of revision before the NTA conducted JEE mains examination start from February, and then we have the other shifts of March, April and May. Okay, so the main idea of this particular series has been explained already in another announcement video. So I'll tell you the gist. The idea is to present a topics previous year's questions, try to see that kind of questions that are asked, and try to help the students with the solutions which are standard ones, and also the multiple methods to ensure that they solve them in a better manner, saving time in the exam and thereby scoring better. Okay, so the whole idea is explained in this announcement video that is right now, the thumbnail of which is on the screen. So the link of that video is in the description below. So in order to have a very good understanding of what this series is going to present to you and how it is very important for the students who are aiming at a good score in JEE mains physics, right? Please make sure you watch that entire video, and the link of which is in the description below. Okay, right. So I hope you understood the essence of this particular series. And in case you are also looking at a practice for extra syllabus for the JEE mains, which is kind of a thorn in the flesh for the preparation of JEE mains. Okay, so there is another series that is already running in this particular channel about the extra syllabus previous year's questions. All the concepts are explained through the questions. Okay, so it is a double bonanza where you would be solving the previous year's questions, and also you'll be understanding what is required of you in the examination. So already we have done January 2020 shifts, and the entire March 2000 March and January shifts of 2019, right? Both the shifts, March, I think April, somewhere around that. I'll be adding the September 2020 shift videos to this series also. So this is extra topics or extra syllabus series separately for those students who are looking for that. Okay, so this link of this playlist is also in the description below, so please make sure to go ahead. So let us now start off with the first question. Okay, so you could clearly see on the screen there will be questions with the exact the shift or the year in which the question has appeared. I'll request you to pause the video and try to have a pen and paper in front of you, in case obviously if you're a JEE aspirant, otherwise you can keep enjoying the video, and try to give it a fair try of 1 or 2 minutes, and then go ahead for the solution explanation. I'll keep going question after question in a sequence of a certain topic. Okay, right. So um, and this one is a one-dimensional motion question. So let me go ahead with the formal wording. A particle is moving with a speed of v is equal to b root x along positive x-axis. Calculate the speed of the particle at t is equal to tau. Assume that the particle is at origin at t is equal to 0. Okay, so I hope you have given it a try. Let's move ahead. Okay, there'll be a lot of things on the screen. Whenever I am explaining, try to follow my lead. Okay, so this is the usual method that you would see on internet in the standard books or anything. So I have nothing against this. So students are supposed to know this usual method. So I'm leaving it to you to go through this calculus way or the differentiation way of solving, where you write v as dx by dt and then integrate and get to the answer for v as a function of time. Okay, so there's another alternative way of looking at this specific function that often repeats in the JEE mains examinations. Whenever v is proportional to root x, it should bring your mind back to a simple situation where you can write v is equal to root of u square plus 2ax, specifically whenever uniform acceleration is given. We have a complete chapter of motion under gravity which functions on this. Okay, so in this problem, when v is given as root of b square x, I brought the b inside, you realize and compare these two with the initial velocity equal to 0, that the value of acceleration is b square by 2. You can clearly see that comparison. Okay, so immediately you can write v is equal to u plus at, and without any calculus, within one step, you can directly arrive at this b square t by 2 and score some time also apart from scoring marks. Okay, so that's the alternative outlook I would request students to have whenever a root x function is given for velocity. And here is a sample practice question where you could see from a previous year paper, the similar question has appeared. Obviously here he has asked displacement as function of time. So if you can master the idea that I told you, you can answer this without even putting pen on paper. So have a try. In the next page, there is the solution for it. I'm not going to explain it. So once you're trying, done with trying, you can go ahead and look at it. Okay, so this is the solution. The left side, you have the solution given in a standard manner. Now, can you practice the alternative way that I have already taught in the previous question? I hope you can do that. Okay, let's move forward. Here's another favorite question, which is of the chasing type of questions in one-dimensional motion. The velocity time graph of a car and a scooter are shown in the figure. Okay, so this one is car and this one is a scooter. The difference between the distance traveled by the car and scooter is 15 seconds, it seems. Okay, and the time at which the car will catch up with the scooter. So these are the two questions from the graph you have to answer and then match the correct option. Okay, so this was from 2018 paper. Okay, so give it a fair try after pausing the video, and here I am going ahead with the solution of that. Again, two possible ways of solving the problem. The usual way is to look at the graph, write all the equations. You have a straight line v versus t. It's a constant acceleration motion. So you can use the standard rules and regulations of that particular motion and get to the answer. Okay, so that way, again, it's a safe way of solving. But once a straight line graph is given in velocity versus time graph, this is the way I would request the students to look at the problem. Okay, so when he's asking what is the difference in the distance traveled, difference in the distance for one-dimensional motion would be area under velocity versus time graph, right? So the car area will be this big area entirely. If you watch the screen carefully, the way I'm painting this entire thing, and the scooter area would have been this rectangular area. So when you subtract this part, which I did not shade, will get completely cancelled off. Okay, right? So the area of the triangle and this area of this trapezium, which I dotted, this one's, if these two are equal to each other up till whatever time that you are looking at, that is when the displacements would be equal, and that is when the bodies will meet with each other. Okay, so this area, which is easy, right? Area of a triangle is half base into height. And area of a trapezium, you all know, is half into the distance between parallel sides, which is nothing but this 15 multiplied by the average sum of the parallel sides. So you need to just write it as some t, which you don't know. You have to calculate the time after which it happens. But the starting point is clearly 10 here, and then you can evaluate it much quickly as compared to what you had done in this particular fashion. Okay, so have a pen and paper and try that alternate way of solving both the things. And if you carefully observe in the exam, all the four options are different. Okay, so you could see there is nothing common between the two except the options C and D. Okay, right? So you should be able to guess that C or D could be the correct answer. So it would be better if you solve for only the second part, that is the time after which the car will catch. That is when the areas are equal under the graph. So if you do that part only, leaving out this calculation, I think you can save time in the examination. So that is how you'll get the option C. Okay, right. Let's move forward. Right. Next question is another interesting one, right? That keeps appearing a lot of times in the JEE mains exam. It's a multi-conceptual question, so I'll give you the usual solution also as usual, but the unusual one is the one that attracts me. A man in a car at a location Q on a straight highway is moving with speed V. He decides to reach a point P in a field at a distance D from the highway. Okay, so he wants to reach here. That from that point M is the distance D. Speed of the car in the field is halfway to that of on the highway. What should be the distance RM so that the time taken to reach the P is minimum? Okay, so he's traveling on the highway. He can take a turn from anywhere here and reach this point. So among all those motions that he can possibly take, which situation gives him the minimum calculation of the time. Okay, so how quickly he can reach here is the situation. Okay, so give it a fair try and let's move ahead. So the left side, as usual, the solution based on the calculus. Whenever minima or maxima is asked in mechanics, I think we build a function and we try to take the differentiation of that equal to 0. So I will leave you to go through this solution on your own. For me, the alternative outlook is the more interesting one. So this green one is the highway, and this is the point where, let's say, the red one is the trail of the car or the car that is moving. So imagine he takes a turn at this particular place like this. Okay, right? And this is your R point and this is your M point like this R and M, I'm marking them here. Okay, now if any straight line motion, it has to take a turn like this is equivalent to a light which is getting refracted when there is a medium change. And the medium change is depicted by the velocity of this car in this grassland is v/2, and on the highway it is v, similar to the light traveling with different speeds in different media. So for this kind of a grazing incidence and going off, this would be a critical angle, and Snell's law for critical angle always, or the by Fermat's principle or rule, tells you that it takes the least amount of time. Okay, so we are using the multi-concept of light to solve a kinematics problem. Okay, so v divided by sine 90, okay, is equal to v/2 divided by sine c, should give you c is equal to 30 degrees. So in all of this left side calculation, we'll directly arrive at the idea that he has to take a turn making an angle 30 degrees with the normal. Okay, and then Rm, which is this distance, would be simply d tan 30, and it could be d/√3 within a very simpler calculation. I hope you like the way we incorporated the Fermat's principle in calculating the least amount of time. Okay, let's move forward. Another relative velocity question, and this question, just have a read, try it out, and then I'll try to make sure that you understand why I've selected this question. Okay, so there's nothing difficult about this. Okay, right, let's move ahead with the formal wording. A passenger train of length 60 meter travels at a speed of 80 kilometer per hour. Another freight train of length 120 meter travels at a speed of 30 kmph. The ratio of times taken by the passenger train to completely cross the freight train when they are moving in opposite direction and in the same and opposite directions is, okay, is asking a ratio. By now you have understood why the question has been selected. These type of questions look lengthy and look like there are two cases and all that, but these are actually very scoring ones. If you are very careful, the ratio type of questions where too much information that is given in the question is actually not needed. So the idea is very simple. Whether the train 1 or train 2 is going to go in same direction or opposite direction, irrespective of the length of the train, you don't need the lengths to be taken in your calculation. Right here I have written it so that you can understand it, but the time taken in case 1 and case 2 is purely depicted by the relative velocity, because it has to cross the sum of the lengths always. So that extra information in the question, it need not be used, and you can save time in this such type of questions. Okay, so it would be the inverse ratio of the relative velocities from case 1 to case 2, and directly you can use that 80 and 30 and get to the quick answer in this particular question. Answer would be, I think, 11/5. Okay, right, let's move forward. Right, a tennis ball is released from height h, and after freely falling on a wooden floor, it rebounds and reaches height h/2. Okay, right. The velocity versus height of the ball during its motion may be graphically represented by, they're not drawn to scale. Okay, so this was in September 2020 paper. Okay, these type of questions quite often get repeated about the motion under gravity graphs. Like they can give you y versus t, v versus y, and a lot of other v square versus a. So just have a good practice. But there is one important thing: by looking at the options. Okay, so after looking at the options, you will have a gauge or an idea of what the examiner is after. That saves a lot of time. Okay, so I hope you give it a fair try. And here we are going into the solution. Okay, so ask yourself, uniform gravity means uniform acceleration, right? And dv by dt has to be a constant. Therefore, dv by dh can't be a constant. Therefore, v versus h graph cannot be a straight line graph. So immediately option A is ruled out. So you have to go by your gut feeling and rule out options in such questions to save time rather than actually deriving the entire stuff. Okay, so here we go with the usual solution on the left hand side. Okay, right. But my idea is on the right side, just get the G as constant and dV by dH is not constant and eliminate options very quickly. And once you start doing that, you would realize with the arrows given, the value of this velocity, right, whenever it hits the floor, right, whenever it hits the floor, it has to reverse, right? So it cannot be option D. So A and D are already eliminated. Our next job is to check whether you have to mark B or C, and it obviously tells you that whenever your dV by dH is going this way, right, it is going to have very large value, right? dV by dH can't be infinity. So you have to check that dV by dH should be a finite value, and also velocity has to change direction. So the best possible answer, without any calculation, should be the option C. Okay, so yeah, this is a usual solution also. You can go ahead and watch through, but I would say that you can easily guess the answer to be 3 and save time for other questions in the paper. Okay, so let's move forward. So this is a similar practice problem on y versus t this time. That was v versus y. So just to tell you, these kind of questions are often repeated, right? So please make sure you go through such examples. Okay, so there's a solution in the next page. Only after trying, please go through that. So here's the solution. So I hope you've gone through it after trying. So let's move forward. Another one, this was a numerical based question that was asked in January 2020, right? So the type of model that they have incorporated in the JEE Mains of late, okay? Right. A ball is dropped from top of a 100-meter high tower on a planet. In the last half second before hitting the ground, it covers a distance of 19 meters. Acceleration due to gravity near the surface on this planet is. So you can't use this 10 meter per second square always. Okay, so give it a fair try. I'll go ahead with the solution of the problem. Okay, so here it is. Right. So the thing is, there are usual and alternative outlook. Always don't think the alternative outlook I'm going to provide is the superior one. People going ahead with the standard solutions also can like that. So I'm not saying my alternative outlooks are always the superior ones. Okay. So having a second method always gives you a better visualization of the subject. Okay. So the usual outlook would be to write S is equal to UT plus half GT square. G is not 10, by the way. And from the top of a tower, when you are dropping a particle, you can calculate T is equal to root 2 H by G. H was given as 100. So the total time of descent is easily written as root 200 by G. In the last half seconds, he told that it was covering 19 meters. That means in the T minus half, always remember it's easier to calculate the time from the top to a position because initial velocity is 0. So instead of calculating it for the last 19 meter, you'll calculate it for the first 81 meters. Easy. And 81, it gives you a hint that it's a perfect square also, which makes our calculations simpler. Okay, right? Always search out for these kind of numbers, right, where perfect squares are there, right? So when you write it for first 81, you'll get two equations in T, okay, and G. You have to eliminate T, so subtract the two and you'll end up getting the value of G, which is 8 meter per second square. My way of also looking at it is knowing the fact that from the top of any tower of height h, if I drop a particle, it hits the floor with root 2 gh speed. Okay, and g is not 10, by the way, so I substituted the value of h as 100 and I noted it as 10 root 2 g. Then for this last 19 meter, if you insist, I don't want to go by the usual solution. If you insist, I want to use this 19 meter with final velocity known. Remember, during this 19 meter, this is the final velocity. This is a formula that is less used by the students. A more famous form is S is equal to UT plus half AT square. But if you already know V and a time period for a certain motion, you can also go ahead with S is equal to VT minus half AT square. Okay, so S is known, V is just depicted here, T is half second he gave, and you're getting a quadratic in root G. Okay, so not very straightforward. The same amount of calculation that you'll have as you had in the usual method. So I won't claim that this is a superior method. I just want to introduce the students to this less looked formula, which is a pet of JEE advanced exam people. Or there have been questions where they, if you use this as formula, you'll get answers quickly. So keep that also in your mind. that you can use this formula. Okay, so we'll end up getting 8 meter per second square. Okay, so next one. Uh, the other type of kinematics questions are based on vectors. Vectors seem to be one of the favorite topics of JEE Mains. Not much vectors are asked in JEE Advanced, but JEE Mains makes it a point that they at least ask 4 to 5 questions across 8 papers in a particular shift. Okay, so let's see some of the standard, and there are quite often repeated models. I've picked only 2 or 3. If you see the previous papers, then you will see like quite a few number of models are often repeated. Okay, so here's one of them. The sum of two forces P and Q is R, and such that the modulus of R is equal to modulus of P. The angle theta in degrees that the resultant 2P bar and Q will make with Q bar is. Okay, right. Again, there are more than one method of solving this. All right, the standard way is to write the equations, which is on the left side. Okay, right. He has given you that P and Q when added produce a resultant whose magnitude is equal to P. So there is some kind of isosceles triangle. So in my alternative outlook, I'll draw and solve the problem in one step using the geometry part of it. Okay, so the green one, P and Q, can you carefully observe here, when added gives you an R. Since the magnitude of R was same as magnitude of P, I should have PQR as an isosceles triangle, which is, I think, straightforward and acceptable to you people. Now, when someone says 2P plus Q, I have to add. Okay, so 2P means I have conveniently marked another P parallel to this P so that I can say this entire thing is 2P. No objections, I think, here. Then you realize that whenever you are going to add 2P to Q, I need another Q here, right? So I draw a parallel Q. Then I get an idea that I have a nice looking geometry for this where the triangle can be doubled. Okay, right? So in the 2P plus Q, that addition I'll make is this one. This is my 2P. Can you see that? Okay, right? And let me mark the arrow. And this is my Q, only up till here. Okay, right? So if this is 2P and this is Q, then 2P plus Q comes out to be this way. Can you see that? Okay, right. Now I'm claiming that this is going to be 90 degrees because of the midpoint theorem. So if in a bigger triangle, I have this as a midpoint. How do I know this is a midpoint? You could see that this is 2P, therefore this has to be midpoint. So this has to be the 2Q. So entire triangle has to be double. So when I am adding this 2P to this Q, which is the midpoint of a bigger triangle, this resultant has to form a perpendicular bisector with it. So which is what he has asked. This 90 degrees can be depicted on a geometrical format, which makes the problem more visually pleasing. I'm not again saying alternating outlook is the better one. Usual solution also will give you that, but in case it doesn't strike you, always think in a geometrical manner too. Okay, right. So here's a practice problem, and always don't try to think in a geometry also. Usual way also will give you solutions in some situations, in some scenarios. Okay, and also look at the options. Okay, so of this particular practice question, and that should tell you whether you should go ahead with a usual equation based solution, or if you want to go ahead with a geometrical way of answering the question. Okay, so here's the solution to the practice problem in a usual manner. Okay, so next one is another question about the forces, vector form. Two forces P and Q, magnitudes 2F and 3F respectively, are at an angle theta with each other. If the force Q is doubled and then the resultant also gets doubled, okay, then the angle theta is, he's asking. Okay, so give it a fair try and then we'll move ahead with the solution given. Again, in this scenario, you might be thinking about some geometry, right? So I just wanted to give one more question where always have the usual solution also at the back of your mind. Don't try to become funky in the examination, try to think of all those things. Some of the practiced questions, if you have a geometry in mind, it's okay, it will give you an edge over others. But you don't get it within 15-20 seconds of reading the question, just fall back upon the usual method. In this case, you would say standard solution would be the best, because making a 2F and 3F and 5F, these kind of numbers in a geometry is difficult. Doubling something, that's easy. Okay, so standard solution is the best. Write the resultant equation that you always write, and write the two equations that he has given, subtract, eliminate the value of F, and get the value of theta as 120 degrees. Would have been very difficult if I had used geometry here. Okay, so Let's move ahead. Here's another one. Let's try to check our luck whether we can solve it in one method or two methods. Okay, so this was a January 2019 question. Two vectors A and B have equal magnitudes. Equal magnitudes we can manage, I guess. Okay, so I think some of you might be already thinking of some cute thing to do in this. Okay, the magnitude of A plus B is n times the magnitude of A minus B. Okay, then the angle between A and B is, okay, some of you might be substituting some values for n and all, right, 1 0, and just try your luck out in that sense. Also try to practice that way also, but I would go ahead with the two solutions here. One is the standard one given in textbooks, the left one. I think you can go on your own and check this one out. But for equal magnitudes, I would like you to have an alternative view. And remember, whenever two equal magnitude vectors are added, of let's say magnitude A and angle between them is theta, then the addition is given by 2a cos theta by 2, which is nothing but just making sure that you write the half angle form of this 1 plus cos theta that you see here. Okay, 2a cos theta by 2, very useful. And the subtraction between the two vectors is simply 2a sine theta by 2. You can easily see that in the geometry of this figure also, right? So whenever you have this isosceles triangle, like in the previous problem, this would be the perpendicular bisector, right? So this value would be equivalent to the 2a, sorry, this would be a cos theta by 2, and this would be the double of that. That's how I get this. Whereas this green length would be a sine theta by 2, and this entire thing would be the double of that. Actually, I could have completed a rhombus out of this a and a. Okay, he has directly given that this is n times of this. Directly you get tan square theta by 2 is 1 by n square, and you can write cos theta in terms of tan square theta by 2 in this format, and you'll get to this step in a much quicker manner as compared to solving it all the way. Okay, so here, yeah, having a note about the equal magnitude vectors, which are one of the favorite things to ask from the vectors topic by the JEE mains. Equal magnitude results are very, very important, both in a geometric manner and also the trigonometric manner. Okay, so here's another question that is from the past 2015 online paper. A vector A is rotated by a small angle delta theta radian to get a new vector B. In that case, modulus of B minus A is, looks scary in options, but I think it's not that difficult. Give it a fair try. And here we go with a simple hint actually. So the left side one is the one that you have it in the standard books. You would say if any vector is rotating and not changing its magnitude, you can depict it as a radius of a circle, and a very small angle between them, d theta, will ensure that the straight line path and the arc path are almost equal to each other. So the value of that arc length would be r d theta, which is in this problem the magnitude of vector a d theta. So that's how we can directly say the answer in one step. Okay, so the answer should be a, which is like a radius into angle. Okay, right? And that's how when you divide it with dt seconds, you end up getting a into delta theta by delta t, which is the stepping stone towards your formula for the linear velocity in circular motion. Okay, so this is the way they have asked the question about. Next one. Often repeated models of questions are, they give you velocity as function of position coordinates, ask you the general equation for the trajectory or the path. And you could see, as I keep saying, that there are many repeated models. You solve certain number of papers, you'd see that models of these in JEE mains. You won't get that kind of thing in JEE advanced, but where concept obviously is repeated, but in JEE mains with NTS database, you'll have a lot of questions repeated. So without solving the previous at least 2 to 3 years of papers, and especially 2020 papers and 2019, if you're going into the exam, that would be a foolish thing to do. Okay, so here's a very simple example. Because of the length of this video, I couldn't fit in a lot of other such repetitions, but I think this is a very fair comparison from two different examinations. Okay, so now how do you solve this? Solving this is a very standard way. There's no two methods to it. Okay, so you have Vx as y and Vy as x. So dx by dt is ky, dy by dt is kx, divide, and whenever you form a trajectory equation, you eliminate time. Trajectory equation is independent of time. Okay, so dt has to be eliminated, and that's what we have done. And rearranging y dx and y dy and x dx, you should be able to get that hyperbola, which is y square minus x square equal to a constant type of curve that we will end up getting for this problem. Okay, all right. let's move forward. Uh, Another trajectory style equation. Again, there are many ways of looking at it. Okay, so let's see a smarter way also. A particle moves such that its position vector r bar is equal to cos omega t I cap plus sin omega t j cap, where omega is a constant and t is time. Then which of the following statements is true for the velocity v bar? Okay, so he has given 4 of the statements where he's talking about the properties of velocity, acceleration, and position vector relation. So you need to pick one correct statement. Okay, so let's move ahead with the solution. On the left hand side, you have the standard textbook solution. Okay, but once you look at this, you need not do all of this differentiation and all. Whenever you have r cos theta and r sin theta as the coordinates of a trajectory in xy plane, I think you know that the locus of that point should be circular. And apart from that, once the theta, that angle that you have inside, is given as omega t, that means the theta is changing at a uniform rate, which means it's a uniform circular motion. So you are supposed to get to this last line without performing all this with confidence by having this notion. Okay, so that should immediately, once you read the options, give you an idea that option D is the only correct answer in this question. Okay, right. Let's move forward. Another set of questions. Now we are entering projectile motion. So there are two parts in projectile motion. One is projectile on the ground and another one is projectile on the incline. So let's try to see what type of and what style of questions are asked in this particular subtopic. A particle of mass m is projected with a speed u from the ground at an angle theta equal to pi by 3 with respect to horizontal, which is x-axis. When it has reached its maximum height, it collides completely inelastically with another particle of the same mass and velocity ui cap. So it's moving horizontally. The horizontal distance covered by the combined mass before reaching the ground is. There are some 4 options given. Okay, so give it a fair try. It's also not about how you solve, how quickly you solve in a JEE mains exam is also important. Okay, so let's try to see. The usual solution I would request you to go through on your own. The first part is unavoidable, where there is a collision. Obviously there's a one-dimensional collision. Horizontally the body was moving and hitting it at the topmost point. I think you will conserve linear momentum. Therefore the combined body is definitely going to move at 3u by 4 as compared to the initial u with which the speed of the body was thrown at. Okay, what you can do instead of going through this entire calculation is to realize that the body which was moving horizontally continues to move horizontally after collision. So its vertical motion properties have not changed. So time of ascent, which was before, and the time of descent, which will be even after, remains the same, which is u sine theta divided by g. So knowing that the time of descent never changed during this horizontal motion, you would attribute that change in velocity. Remember, u by 2 was supposed to be there at the top, right? U cos theta. It has become 3u by 4. That means the velocity has become 3 by 2 times. Okay, so whatever range that you had, half of the range that you got, which is nothing but u cos theta multiplied by time of ascent. How did I write this range? I did not mug up the formula for the range. I did a simple situation of horizontal component of velocity doesn't change. Time of ascent multiplied by horizontal component gives you this number. Okay, right? At the topmost point, the horizontal component has now become 3 by 2 times with the same time of descent. Therefore, this one, if it is capital X, this has to be 3 by 2 times of capital X. So the value of the required answer, which is what he's asking here, is 3 by 2 times of this in a quick calculation instead of doing all of this. Okay, which essentially is what I did, but we did done it in a pictorial manner. Okay, right? So let's try to go ahead. Another trajectory motion, one of the favorites of JEE. You see the last 10 years of papers, you will find many questions on the trajectory of the projectile. Okay, right. So near the surface of Earth is given by y is equal to 2x minus 9x square. If it were launched at an angle theta naught with speed v naught, then okay, some of the students would be mugging up the formula for the trajectory, and it's good if you mug it up, fine, but I am not a person who encourages students to mug up the formula, because in an exam situations you are generally tense. You might actually end up writing a wrong formula if you write it without understanding. So let's try to see the alternative way of looking at it in exam. I'm not saying it's a superior way, but if you can't remember this left hand side standard textbook formula, it's okay, right? You need to know from where you can get to it. Okay, so this 2x minus 9x square, I can write it with a 2x common and 1 minus x by r. Reason is very simple. When you have a trajectory of a projectile motion, the y becomes 0 twice, right? Once at the start where x is 0, and once at x equal to the range value of r. So this nothing but depicts that two roots of that quadratic expression. And from that, you will immediately get the value of r in this is 9 by 2. Okay, right. So the value of r has to be 9 by 2. He didn't ask it, but I'm just telling you in future question, if someone asks you what is the range from this, I think you can solve it as 9 by 2. Okay, so it's a better way of remembering the formula. Okay, and for the first dx distance traveled, remember, if this is true for every x and y, it should be true for the initial dy and dx. So for this first throw, very dt seconds later, the particle moves a dx and a dy. Then if you substitute in that, the value of this dx divided by r would be very small compared to 1. So for the first small amount of time, this term 1 minus x by r can be negligible and compared to only one value. Okay, so this entire bracket will become nearly 1, and therefore in that scenario this dy will become dx tan theta, where theta is the initial angle with which you threw. Okay, which tells you that the 2 that I brought forward should be equal to tan theta. I hope you understood the logic behind what I did here. That's why this x tan theta becomes important. Okay, so I gave you a way to remember why there is an x tan theta in the front. This dx initially is very negligible compared to 1. Therefore, the first dy and the first dx would be having a ratio of tan theta. So that's why theta is tan inverse 2, which you can easily depict and convert it into cos inverse. Okay, so that's another way of looking at and remembering this particular formula. Let's move forward. Next one is slightly feared topic among students, because students tend to not remember formulae of inclined plane motion, projectile motion. So here we are not going to deal in details of the inclined plane projection, which I've done a particular video also in the past. I'll give you the links of that in the description. But you should understand what style of questions are also asked in the exam. Okay, so let's move ahead. A plane is inclined at an angle of alpha equal to 30 degrees with respect to the horizontal. A particle is projected with a speed u is equal to 2 meter per second from the base of the plane, as shown in the figure. The distance from the base at which the particle hits the plane is close to. That means this goes, hit somewhere. The distance of this hit point from the base is asking is close to. This type of close to means definitely the answers are going to be a tough ones to crack, because they'll be approximate. Okay, so these are the ones which are just slightly lengthy in calculations in JEE mains. Should stay away from these kind of questions till the end of the exam. Okay, right. So again, on the left hand side, the usual solution where you remember the formulae, derive them obviously, right? You can derive this one easily, 2u sine theta divided by the g value in the perpendicular direction to the incline, which is cos alpha, and you'll get that. So all this is the standard textbook rules. There is another alternative way of solving inclined plane projectile problems, which is the vector diagram. Okay, so I have already done a video on this. So in case you want to go through that videos, there are 2 or 3 videos on the vector diagrams and projectile motions, which I have done right at the start of launch of the channel. So links of these 2 videos are in the description below. So please make sure you go through them, and they give you the fresh perspective on how to attack the projectile motion problems. Okay, so I'll give you a gist of that. Any displacement vector in a projectile motion can be written as ut plus half a t square, where in vector form u is a vector, g is a vector. These are constant vectors. That's the interesting part. So when you're throwing a particle at a particular angle, you can use superposition principle and think that for that capital T amount of time, which is time of flight, the ut first happened where gravity was switched off, and suddenly you realized that gravity has to be switched on. You stop the particle here and you throw it down. Okay, right. So this half gt square is this one, this ut is this one. So instead of actually drawing the trajectory, you are depicting the entire displacement in the form of 2 vectors which are not 90 degrees to each other. They are just vector which is in the direction of ut, which is 2t in this problem because u is given as 2, and half at square, which is g being 10, phi t square. So this and this represents the hit point, okay, which is 15-degree triangle. Since this is 30 degrees and this is 15, this is a 45-degree entire triangle, and this entire thing, if I complete a triangle, this would be also 45 degrees. So which means if this is 2t, this should be root 2t. Okay, and what should be this green color? If this is root 2t, then this also should be root 2t, because this bigger thing is a 45-degree triangle. Therefore this red thing should be equal to root 2t minus this 5t square. Not only that, from a smaller looking triangle of 30 degrees, you can write this root 2t into tan 30 here. And this is two ways of depicting this: root 2t minus 5t square and root of 2 by 3t. These two are equal to each other, and that's what I have written here. Okay, right? And from that, you will end up getting the value of capital T, and your job is to get the value of root of 2 by 3 capital T, because he has asked this red color distance, which will give you the same answer as what you got after this calculation. Okay, so this is an alternative way. Again, I'm not saying this is superior, but having this vector diagram idea will also help you ace some problems in inclined plane motion in JEE Advanced also. So it's a very interesting and refreshing topic. So please check out these videos and you would definitely love them. Okay, right. And the second video, especially this lengthy problem on the right side, you will find some important tricks that you can use for future problems also. Okay, right. Let's move forward. Here's a practice problem on the projectile motion. So again, this is a case where a bullet is fired from a pistol, and this time the pistol is also moving. So maximum range questions are quite a favorite among the JEE mains question paper setters. Okay, comment your answer for this below. Next one, let's move ahead. A ball projected from ground at an angle of 45 degrees just clears a wall in front. If the point of projection is 4 meters from the foot of the wall and ball strikes the ground at a distance 6 meters on the other side of the wall, then the height of the wall is. Okay, so here he gives two sides distance of the wall. Okay, so this is a very interesting question. There are ways of solving this. So let's try to see the application of the trajectory equation that I wrote. So on the left hand side, the usual one, I'll leave it to you to check how you can solve the problem. Or the alternative way, I told you already that I derived in the previous problem, y is equal to x tan theta into 1 minus x by r is the best way to remember the projectile motion's trajectory. So with the wall on this side, this is the 4 meter point that he talked about, and this is the 6 meter, which means you could say the value of r is 10 meters. So you just substitute r equal to 10 and tan theta is equal to 1. So this is your trajectory. And then just put x is equal to 4 into that. Okay, and your value of y is 2.4. There's no need to even calculate the maximum height and all this stuff in this problem. That's 2.4 can be easily got if you know this equation. Okay, right. Let's move forward. Another question. I'll tell you the reason why I chose this question. Okay, so these kind of things happen in the JEE mains examination. Okay, ambiguous questions, wrong questions are given, and finally NTA doesn't change the key. Okay, then in such cases, it's always better to assume that the question is not going to get deleted or you're not going to get bonus, and try to answer the most appropriate way of interpreting the question. So try to think what is examiner trying to ask by looking at the options, and then answer it so that you are on the safer side. I know as a physics teacher and a physics student, we should always look at the correctness of a situation, but JEE mains, there are exceptions, and there have been evidences where blatantly wrong questions are also have not been deleted. Okay, so let's look at what this question is about. A clock has a continuously moving seconds hand of 0.1 meter length. The average acceleration of the tip of the hand in units of meter per second is of the order of. Okay, can you guess what's the issue with this question, especially the one that I have underlined? Average acceleration is a subjective thing, right? Average acceleration is change in velocity by time. So I should be told what is the value of average acceleration for which duration you are calculating. If I calculate it for 1 revolution, the average acceleration comes out to be 0. Right? So for complete revolution of the tip of the hand, it would be 0. 360-degree revolution, change in velocity is 0. So there is no 0 in the answer. So that itself should trigger something in your mind that the examiner thought of asking something and he asked something else. try to convert the question to your favor. Okay, instead of average, he's asking the instantaneous acceleration. I know it's difficult to guess in the exam, but that's how it is supposed to be done. So what to do in the exam? Change the question to your need based on the options given. It's just calculating r omega square, which is not average acceleration. Remember, it is the uh, instantaneous acceleration. So this is not average acceleration as the textbook suggests. It should be instantaneous. And the order, you know, you should know how to calculate order. Order is the 10 power minus 3. Okay, so that's what I wanted to tell. Not much of physics in this problem that would trouble anyone. Okay, next one. Chasing problems, relative velocity problems, rain man, river man problems. Okay, so this is the last subtopic. We're almost to the end of the video. When a car is at rest, its driver sees raindrops falling on it vertically. When driving the car with speed v, he sees that the raindrops are coming at an angle of 60 degrees with the horizontal. On increasing further the speed, the car value to 1 plus beta times v, this angle of observation changes to 45 degree. The value of the beta that he gave here is close to, again, close to questions. Be careful, they are approximations. Okay, I think this is pretty straightforward relative velocity problem. So always on the right hand side, you remember velocity of rain with respect to car can be written as, I know velocity of rain minus car, but it's better to always think of it as velocity of rain plus the negative velocity of car. So if the car is moving towards right like this and rain actually is falling vertically downward, you just reverse this velocity of the car this way and add it to the velocity of rain. That the third dimension, that this thing, which is VRC, is going to give you the angle. So you travel faster, this bottom side becomes stronger and stronger, this angle becomes lesser. As you could see from this picture to this picture, this 1 plus beta made sure that the angle 60 reduced to 45. Simply use the tan 60 and tan 45, divide the two, and you'll get beta is root 3 minus 1, which is 0.73 in approximation. Okay, so there's no alternative solution here. I just wanted you to have a picture in your mind to represent the relative velocity as an addition rather than subtraction. It's easy to add. Let's move forward. Another relative velocity questions deal with the shortest distance of approach, where they'll give ship is moving, man is moving, swimming, and then something else is moving in the river, and they calculate what is the relative minimum distance of approach. There could be two projectiles which are projected, and then the minimum distance of approach is asked. Okay, so always the idea is to sit on one of the objects and watch the other. Okay, so let's try to apply that one in this problem of 2019. A ship A is sailing towards northeast with velocity v is equal to 30 I cap plus 50 j cap, where I is east and j is north. Ship B is at a distance of 80 kilometer east and 150 kilometer north of ship A and is sailing towards west at 10 kmph. A will be at minimum distance from B in how many hours? Time is asking, is not asking the value of minimum distance. Slightly more difficult. Okay, so try this one out. After giving it a fair try, we'll go ahead with a solution. So here's the usual way. Actually, this is a very lengthy question. So by looking at the question, I know a lot of times you will not be able to justify how much time it would take, how quickly you can get trapped into the question and all, but within 15-20 seconds of writing down the information and drawing the diagram, you should be able to judge. So the usual way is the left side. Even alternative way, it looks very colorful, but trust me, even in the alternative way, it will take a lot of time to solve the problem. Okay, so the usual way is to depict everything in vectorial I cap and j cap form and get the value of the minimum time using the projection of the distance that would be there divided by the velocity of that relative velocity of the ship. So I would request you to go through this on your own. Whereas the alternative way is to use the trigonometry or the coordinate geometry. Okay, so here I'll try to use the trigonometry part. So look at this, a lot of things are there. Just let me explain. The ship A, let's say, is at origin, and ship B he has given is at some 80 I and 150 J. 8 and 15, you should know that they are Pythagorean part of the triplets, right? 17 is the third side. Therefore, 170 you should be able to quickly write. That should save a lot of time. So the ship B is here, which is supposedly moving towards left. So in the reference frame of this ship, you have to reverse this velocity and add it to the ship A's velocity, just like the rain and car that I've done. Always think of reversing this one and adding it to this. So the ship A, which was supposed to have 30 and 50, is now going to have 50 as it is, but you added this 10 to this 30, makes it a 40 this way. Therefore, the person in ship B will think that the ship A is moving along this blue colored line, which is the resultant of 40 and 50. So this blue line makes an angle theta with x-axis given by tan theta equal to 4 by 5, 40 by 50, 4 by 5. Okay. What is this alpha? Alpha is the position vector of the B's ship with respect to origin, which is nothing but tan alpha is 18 by, 15 by 8. That 150 and 80 was given, right? So that is it. So you have a small little triangle here, which is this 170. This perpendicular distance is the minimum distance, and the ship A takes some time to reach that minimum distance. Do you see a small triangle here? Wherein, if you can get this distance traveled divided by the velocity of 40 and 50 resultant, that would be the time taken. Okay, so not so easy job. You need this angle alpha minus theta. Okay, so that you can say 170 cos of alpha minus theta divided by the speed, which is root of 40 square plus 50 square. How to get tan of alpha minus theta from alpha and theta? I think you use tan A minus tan B, you'll get that. Tan alpha minus theta is a very simple calculation, but getting again cos from that would be difficult, making it equally difficult to what this one is. At times I feel after doing this entire thing that it could be possible that this usual solution also is as tedious as the alternative solution. So this type of questions, again, after writing 2 or 3 steps within 30 seconds, be proactive in the examination to realize that the calculations are going out of hand. Try to leave the question and go for easier ones, and then come back to this only if time permits. Okay, so don't get stuck in such questions for more than 1 or 2 minutes. Okay, so that kind of attitude you should have to be able to leave the question. Okay, so this is one of them. And we'd like to end the video with a simple practice problem after so many tough questions. So a question on relative velocity, which could be simple. Why I gave this one is going by the face value of the previous question. Let's look at this one. This looks very innocent. Do you see this? So people get sucked into this question easily, and whenever they see circles of this kind, they tend to leave these kind of questions. So please do understand, it's a pretty straightforward question. Whenever you see some uniform circular motion question, don't have any phobia for that, right? Normal one-dimensional kinematics motion questions themselves could be tougher than this. Okay, so just to give you that confidence that these kind of questions are easy, I selected this. I asked quite a few relative velocity questions on uniform circular motion. So have a practice on this, and here's a simple solution for that, right? Nothing better than a 90-degree turn. Okay, so to make this job simple. Okay, right? So here that finishes our video. So to stay till the end, I'd like to give you some important things. So this is a kind of a demo video actually of the series that I have started. So I've chosen a simple topic which could be reached to a lot of people who can understand kinematics, try to understand the way this series is going to go on. Okay, so as I keep going into the 20+ videos that I have planning to prepare, second topic would be Newton's laws of motion, that in a sequential order we'll try to end up with EMI, AC, then modern physics, all those things. In each topic, this style of narration from whatever intriguing questions, debatable questions, tough questions, multiple method questions of the previous year's papers, if once you take up, that's I think is the best revision that you could do in the last 40-45 days. Okay, so no strategy, no motivation lectures are going to help you than doing the previous year's question papers. The best motivation and best strategy gets developed only when you do previous year's questions of any national level examination. Okay, right? So instead of searching on YouTube for strategy videos and motivation videos, I would request you to download some previous year question papers and start solving. And that is where I would request you to go to the community tab on this particular channel. I have created a poll because what I think is right need not be always right. So you let me know whether you would like me to continue this particular series by taking topic wise situations. And because if you say no, then I could channelize my energy into something else. Okay, so don't think I'm going to stop the rest of the parallel series that I have already running on the channel. Olympiad workout, all those things will keep continuing, but this requires a lot of effort. So is that effort viable? Is that effort reachable to audience? Is it required for the students? I would like to know. So I've created a poll. So just, you like it and you want me to continue, mark it as yes, otherwise you just mark it as no. I would only continue the second topic video onwards, maybe in from January 10th onwards. I'm planning to continuously upload the videos from topic 2, 3, 4 on, and finish it by February 15th, 10th to 15th, January 10th to February 15th. So from now till January 10th, I'll not be uploading the second video. I'm giving you a chance to participate in the poll. Try to make sure that the number of yeses reach 1K, so that I can actually go ahead and put some effort into this particular series. Okay, try to get your friends also to vote. I'm not asking for likes this time. Okay, right, this is a basic thing that you need to do to communicate to me that yes, you require this particular effort from my side. Okay, right, so try to get your friends to vote. Don't vote from the fake accounts. Okay, to make sure that it reaches. So each one of you vote only once, and try to get more friends of yours to watch this demo video and try to take their opinion. Ask them to come to this community tab and vote. Once it reaches 1K, I'll start continuing with this second topic onwards. Okay, so uh, and otherwise, if the series doesn't continue, I'll anyway put more energies into the rest of the parallel series that are anyway running in this channel: Pathfinder Solution series, Olympiad Workout series, AATS Select, and Resolve series. Links of these are in the description below. If you're new to this channel, check out these 2 to 3 videos in each of this workout series. You'll understand what kind of content and quality is delivered in this channel. So please do like this video and share it as many number of times to your study groups relevant to Telegram, WhatsApp, or whatever you are part of. Facebook, maybe you can share on your uh, status, so that more students come and watch this demo video and also participate in the poll, so as to make sure that the next 40 days of JEE mains preparation becomes meaningful and purposeful. Okay, thanks for staying this long. I like you people, I like your support a lot. And please do subscribe to my channel if you in case I'm not subscribed, and see you in the next video.